Look what melted when I was doing the high current tests. It was the outlet on the Variac, and it seems to have taken the plug on the cable to the outlet I created for the welder, which is my high current source. And this should never have happened. And I suspect the reason it happened is because the Variac was built with this multi-plug style receptacle that seems to be made to take both German or European plugs and North American ones, and I would bet it does not make good contact with the prongs on the plug, and there's clearly signs of heating here. So what we're going to do is take this off the Variac, see if we can remove the receptacle and then replace it. We'll start by unscrewing these screws, and hopefully this thing will come off. It appears to be doing that. Oh, and here we go. It is completely off. And can I make this look at the camera? I can. Here is the offending socket. Kind of a unusual color scheme. We have green that you would think is ground, but I'm not completely sure. The incoming wire has blue and brown, which I believe is the European color code. Here is the blue, but it's almost like this green is the neutral. That's very strange. And yes, look at that. Nicely frayed wire here. And green seems to be going underneath to the inside of the transformer. And this striped green and yellow appears to be the real ground. So that's very bizarre coloring. I guess you get what you paid for. I paid $60 for this used on Kijiji. I would bet you it didn't cost more than $100 new. So let's see if we can get this socket out. I'm not too worried about damaging it at this point. Does it have some sort of a click-in release? And I think it sort of does. Doesn't actually have much give to it. Yeah, now it's coming out. Sort of. And part of it broke. No big loss. Certainly doesn't seem to be too happy at coming out. I'm wondering whether some of the melting may have had a bad effect. Oh, and you know what? I think the melting has had an effect. I don't know if you can see it, but down here there is some warping of the plastic. So that's what's holding it in. That's why it's breaking like that. So we may not be easily able to get this thing out. One thing's for sure, this is going to make it easy or easier to see what went on inside the outlet. I was sure not expecting it to be this hard to get out, but that's what happens when plastic deforms. Guess I should be a little bit careful so I don't mess up the meter here. Actually, maybe I'll try cutting it. Ah, that might have helped. Maybe try doing that here. Here's where the plastic melted. Yeah, that's where it deformed on the bottom. Oh, I think it's coming out. There we go. So here is our fabulous outlet with the color code that no country in the world uses. What I'm going to do is replace that outlet with this nice new good quality 20 amp one. And one thing I did want to do is see if it would fit nicely, and hopefully I should have a working Variac again for the next series of tests. And after I've done all of that, we will take a look at this outlet. We'll maybe Dremel it apart a bit more and see why it is acting up. So the first thing I'm going to do is mark a bit of a template on here as to where the holes are going to have to go. And luckily the original rectangular hole is almost the right shape to just Dremel a little bit larger for our North American good good quality socket. And how does that do? Yeah, we'll just grind off the end a bit and it should be perfect. So what I'm going to do is use these crimp-on terminals, which are the right size, and I think the trick will be is to cut these off, strip them, and then attach the crimp-on terminals to the wires. Because the color codes are completely messed up in here, what I'm going to do is plug the Variac into a socket, and I know that this is the neutral, and we'll see if there is enough resistance that I can actually tell which one is which. I'm going to attach the one probe from the meter to the neutral, and what do our resistances look like? This one is 5 ohms. This one is 0.6 of an ohm. So my guess is this one here is the neutral, and that would actually be a good guess because it is attached to a wire that goes directly out the cord. Would also mean then that the other side of this receptacle is probably the live, and in theory if I turn this up to about 120 volts we should have a minimal resistance. No. Well, maybe there. So we have about 1 ohm between the green and what is the live on the plug. And if we were to look at the neutral, what do we get? Also about, well, even less than that. So that's not helping. Even at that, even though the neutral is only giving us 0.9, 0.8 ohms to what I think is the live, when I attach it to what I think is the neutral, I get about 0.6 ohms confirming that, or somewhat confirming that. So I think we're going to assume that this is the neutral. I'm going to attach this to the neutral terminal on the replacement plug, and we'll then test and see if it really is neutral when everything is up and running. We certainly get a misconfiguration, and of all the things it says the ground and the hot are reversed. That really does not make sense. So I think what we'll do is just test the individual pins on our plug and see what they are. To get access to the 3 pins to test, because this is a tamper-proof receptacle, what I'm going to do is put this plug in there, and I've been very careful to make sure the Variac is unplugged. I've set up a voltmeter, and what I've done is I've attached its common lead right to the ground in the wall because I don't trust anything around here. And now the Variac is plugged in and turned on. We get on what should be neutral 120 volts. We get on what should be live something around half of that, and we get on ground what really is ground. So I think our little tester isn't quite working properly because of the nature of the situation, but just for fun I'm going to turn the circuit breaker off. We get live on what should be live, and we get live on what should be neutral. So what in fact actually is happening is somehow inside it the incoming live is attached to neutral and the incoming neutral is attached to what should be live in the circuit breaker. So how do we take this thing apart? Well, let's see. Oh, well, that's very nice. The bottom doesn't even have a bottom. But I think what we're going to have to do is take off all these screws, and then I guess maybe take the top off. I'm beginning to wonder whether somebody's fiddled with this or whether it was in fact messed up right from the beginning, and it looks like somebody's actually maybe taken it apart. So it's hard to know who to blame. I did get this used, so, well, you never know what you're getting. All right, so let's look. Oh, here we go. This is loose. I think there's a screw hidden under here. I don't remember from when we had it off, so we'll just take this off one more time. That's what it was. Okay. So what do we have here? Well, we have this red, which is going to the maybe 90% point around our variable transformer. So this is clearly what should be live. And we have a green, which is going to our movable contact. So that is the output live. So that green, in fact, is correctly attached. And then we have this over here, which is neutral, and that would be correctly attached. It turns out in the European color code, blue is neutral and brown is live, and they have been swapped. So I don't know if somebody changed the cord on this or if it was miswired right from the start, but one way or the other we're going to have to fix it. So maybe we'll just try holding these latches open with a screwdriver. Open with a second screwdriver. Oh, and this comes out. Yes, so we have the opportunity of just unscrewing this and removing the blue wire and desoldering this brown wire here. And you know what? This blue, the neutral blue, is in fact going to match up with this neutral blue, and everything will be great. We can just unscrew this and remove the blue wire. And is it going to come out? Yeah, oh, what a messy job. And we'll now desolder that and do the swap. This is where a soldering gun comes in handy. You know what? This is actually just soldered around the wire. So I think what I'm going to do is just make that joint a little bit better with some new solder like that. So what we'll do is we'll cut this off. Strip it, see how well the solder sticks to this wire. Rather nicely. So we'll put our proper hot wire back into the circuit breaker. And it very much looks to me like somebody's been in here, so who knows what's happened. It certainly looks like a fairly old Variac because it's quite dirty up there. There we go. So we can just shove this back in here. Take this out. And our now properly wired circuit breaker is there, and we have to figure out a way of getting all our neutrals, our blues, together. And I think what we're going to do is, we will take this off and recrimp the two blues and the red all together. All right, so I have one of those crimp connectors, and we'll just cut this apart and recrimp everything. And luckily, I think there's still just enough wire to be able to do that successfully. There, the copper is just peeking out the other end. So we will crimp it. There we go. And yes, there will be just enough space for everything to work. All right, so this looks good now, but I think what I'm going to do is clean this a little bit, maybe just with some paper towels dipped in water, just to make this maybe a slightly better contact. So I don't know how well this will work. Oh, there's a lot of gunk there. Well, the brush has still got quite a bit of future wear to go. Do we even dare just turn it on like this? I think we will. What I'm going to do is put our trusty tester here, and now I'll plug in the Variac. What does our tester show? Our tester shows all good. So that was a successful fix. So now we have the fun process of trying to put it all together again. And while I'm screwing it in, you really wonder how it got in a state like that, whether that was somebody doing a fix or whether it was just totally miswired when it was made in China. And well, it worked, and that's all people cared about. So we will turn it on one more time just to confirm that everything is good. It's off and everything is off. We turn it on and it's on. And yeah, as we turn the voltage down, the greens disappear. So we have a nicely working outlet, a properly wired Variac, and that really ended up being way more work than I expected, because all I was intending to do was to replace the outlet here with one that wasn't melted. Well, that brings this video to an end. I hope you enjoyed it. See you next time.